So, as announced before, we are going to have a quiz next week. On September 25. We are going to have a 1-hour class, so from 2 to 2:50 we will have a class, and 3 so it's a 2-hour quiz, and you can prepare 2-page trading sheet, A4 size, handwritten, and you may need a dictionary, and also you may need a calculator. You need to calculate the cosine, find the theta. For example, A dot B, AX, BX plus AY, BY, example. AZ, BZ is AB cosine theta, which is the square root of AX squared plus AY squared, AZ squared, BX squared, BY squared, BZ squared, and cosine theta. And then maybe you need, I will ask theta is in. So for this kind of problem, you would need an engineering calculator, but no auto, no messenger, etc., etc. No text. So even though you can use a trading sheet, you cannot discuss the problem with your colleagues. That means, so there is no talk, no Kakao Talk, no messenger, no whatever. So any questions about next week's quiz? So from the first day to whatever we covered today. So 2 hours will be actually quite a long time, and I think it will be very busy. And read the problem very carefully. As I mentioned before, sometimes I gave you a very easy problem, such as what is your name? But some students wrote my name, or vice versa. So we have covered. The most important material you need to prepare is a 2-page cheating sheet with a handwritten. That means no copy, no reduction. So previously we covered the basics of a vector calculus with the gradient, curl, and Laplacians, right? And today we are going to cover some vector integrals. So before I cover the vector integration, I like to review a brief of mean value theorem. You probably learned this during your high school calculus or the freshman calculus. That is basically A, B. If you integrate this, this is fx bar b minus a. X bar is between A to B. So anybody remembers this mean value theorem? Raise your hand. Probably you have learned it as a way of a 중간값 정리, right? So let's check some simple cases. For example, if we have fx is x cubed, assuming that you are integrating from 0 to 1, you know the exact value, right? So 0 to 1, fx dx is x cubed dx is 1 over 4x4, 0 to 1 is 1 over 4. So we know the exact value, right? So let's check the mean value theorem. If we set x bar as 1/2, what happens? So we say this is x bar is 1/2. Then fx bar b minus a is 1 times x bar is 1/2, so 1/8, right? So 1/8 will be less than the exact value. So that's your estimation, the first estimation using this. On the other hand, if we can set x bar as somewhere in between, for 3, x bar for 3, then fx bar times 1 minus 0 is 3 over 4 to the 3 times 1 is 6427, which is actually larger than 1/5, right? So we know that x bar lies between x equal 1/2 and x equals 3 over 4. So somewhere in between. So we can actually reduce, you can try another half point. So we know that maybe we can try another point. So what is the point between 1/2 and 1/4 to the 3? Let me check. The distance is 4 over 3 minus 1/2 is 1/2, 1 to the 4, right? So you can choose some point in between. So we know that a center point as a 1/2 plus 1/8, 8 over 5, right? So let's try to estimate here. is 125. That's 64 times 8. 512, 125 is less than 1/4, right? So we know that now the x. So from this we know that x bar is in between 508 to 3/4. But actually, this value is close to 1/4. So anyway, so mean value theorem, you can reduce another half. So maybe next time we'll be even closer. But you know the why I'm doing this, right? So you can approximate the integral by the value of the function at the midpoint times the distance. And then you can actually expand this to more than 2 dimensions. So A to B, C to D, F x y dx can be also approximated by F x bar y bar times B minus A T minus C, right? So x bar is between A to B, y bar between C to D. For three-dimensional case, we have A, B, C, D, E, F, X, Y, Z, dx, dy, dz. It can be also F x bar, y bar, z bar, b minus a, t minus c, f minus e, right? And here the mean value theorem dictates that x bar will be between a and b, y bar will be c and d, c bar will be e and f. So using this, so actually we can do some vector integration. I just wrote down the mean value theorem in 2 and 3-dimensional cases. And so that's basically, this is area, right? And this is basically volume. So can I move on? Yeah. F. Oh, which one? On the top? Oh, right. dx, dy. Sorry about that. X bar will be A and B, Y will be C and D. Second line? X is between A and B. Open up. Y is C and D. Let me check it. Let me point out using my pointer, and then you can say. So could you kindly dictate which one? X bus range here?
Yeah, and between A and B.
is actually x, y.
That case x, y is only linear.
Yeah. So I'm saying this is first part is x, this is y. Same as for x, y, z. So I see. You might confuse this is x, right? And then you saw this is y. It doesn't matter actually. So let me point out this is for x. This is y. So this is x, y, z. Then that's okay, right? It's not confusing. So let's try to do some integration. For example, and let's say center is x, y, z. And assuming that we have this vector function f x, x, y, z, x, f, y, x, y, z, y, plus f, c, x, y, z, z. And we are interested in the following integral, f, dr. This is a, b, c, d. A, B, C, D. So, assuming that we are interested in calculating this line integral from A, B, C, D to A, right? So we can add as A to B, F dr, B to C, F dr, C to D, F dr, plus D to A, F dr. So I'm going to denote this is a 1, 2, 3, and 4. So let's do it one by one. So I like to divide some space. First one. dr will be in this direction, right? So dr will be dxx. Because it's from A to B, it's pointing A to B. So this dr will be from A to B, right? So that will be, so f dr will be f fx, oops, sorry, fx dx. So this integral a to b fx dx, so let's say some midpoint x minus x y minus delta y over 2 c. This will be given by this fx, something like x bar minus delta y over 2 z and delta x. Right? And you can calculate the 3. For 3, dr is pointing this opposite way, right? So here, dr will be minus txx. Direction is pointing minus x direction. So fdr minus fx dx. And this point will be xy plus delta x over 2z. So this line integral c2t fx dx will be minus fx x bar y plus delta y over 2z delta x. So can I move on, or you need time to copy? So 1 plus 3 is fx x bar y minus 2 over delta y z delta x minus fx x bar y plus 2 over delta y z delta x, and this becomes minus over fx x bar y plus 2 over delta y z minus fx x bar y minus 2 over delta y z delta x, right? Looks a little bit complicated, and then in that case, what you can do is do nothing, right? So let's try to divide by delta y and multiply by delta y. So I haven't changed anything, right? But what is this? It's a partial derivative by delta y, right? So we can write this way as minus partial y, partial fx, x bar, and at some point y bar z, delta x, delta y. And then you can actually apply the mean theorem back as minus dx dy, right? We can do the same thing for, so remember this formula. So we have done only half of the integral. And So this is 2 and this is 4, right? So at this point is x plus delta x over 2 yz. This point is x minus delta x over 2 yz, delta x, delta y. So along 2, dr will be which direction? Going up, right? Going up in y direction. So this is x, this is y, so this is dy in y direction. So FDR is basically Fy ty. So this BC integral FDR is basically BC Fy dy, and then using mean value theorem, we have Fy x plus delta x over 2 y bar z delta y. And I need some more space, so I will just borrow this. Likewise, for this integral, for the line number 4, it's pointing down, right? So minus y direction. So dr should be minus y dy. So FDR is minus Fy dy. Then T2a FDR will be same as this, minus Fy. However, this is x minus delta x over 2 y bar z delta y. Even though we have some space, maybe I should move to the next page, and I'll let you copy whatever I haven't finished. So can I move on, or you need some more time? Correct? So, bit complicated, I guess. So, can I move on to the next page? So, first case, right? So 2 is this plus, 4 is this minus. So if we add them together, we have the 3, 2 to 4, you have two was a B to C, FDR plus D to A, FDR. So simply Fy x plus delta x over 2 y bar z delta y minus Fy x minus delta x over 2 y bar z delta y. Let me check the Fy x plus delta x over 2 y bar z minus Fy x minus delta x over 2 y bar z delta y. And as before, we can divide by the whole thing by delta x and multiply by delta y. Then this is nothing but partial x partial Fy, x bar, y bar, sum between delta y. This is x This is x. Delta. Okay, so you can go back to this. Partial x, partial fy, dx, dy. So this is ABCD. The area is ABCD. So if we add them 1, 2, 3, 4 all together, what happens? 1 plus 2 plus 3 plus 4. Anybody remembers the previous result? Which is actually f dr is partial x partial fy minus partial y partial fx dx dy. This looks familiar, right? What is this? Z component of col f. This is same as col f z component. Or you can write down this way, or this way, col f z dx dy. So this is same as this is this. So we have x, y, z. So we have this area, and z is this normal to this. So z is normal to xy plane. So we are going to generalize this to the following. Assuming that we have some curve in 3 dimension, this like in general direction, we have a normal vector. This is called surface, this is called S. Normal. Let's say this is a closed curve. C is closed curve. Then the general result is this. If we have closed integral f dr c, the same as two-dimensional integral col f and ds over s. So I only showed this for this proof for xy plane, but you can actually do at home for this is called the Stokes theorem. And Stokes theorem is probably one of the most important mathematical theorems. theorem in history. So I will give you some homework. Show the Stokes theorem in XZ plane and YZ plane, right? As using the same method, as shown in the class for XY plane. And when I say homework, you just do at home. You don't need to turn in, you don't need to submit. Just do it at home and don't bother to give it to me. But homework may be important because I might ask the homework at quiz or finals. And I'd like to make a comment about this Stokes theorem is why it is important. 그러니까 태국면을 따라서 선적분 해준 게 2차원 면적분에 대한 펄 값하고 같다는 거지. 면적분이랑 선적분이랑 연결되는 거예요. 이걸 스톡스 theorem이라고 그래요. 예.
PDF 파일을 그냥 안 올려주나요? 강의 파일?
올려놨는데
네, 유튜브만 올라오는데.
그래요? 조교한테 물어봐요.
그리고 저희 그 다음 주에 1시간 수업하고 시험 치잖아요.
네.
그 수업 내용은 시험에 안 들어가는 거예요.
네. Stokes theorem is important. Remember the first equation of Maxwell's equation, that B. Remember that? If you have a closed curve, this is C. This line integral, CE here, is called voltage. Induced voltage, EMF. So if you have closed the metal ring with very close to each other, then DL becomes curl E to this normal vector, right? ds becomes, because of this Maxwell's equation, it becomes minus round T round B and ds minus round T round B and ds. So this is a magnetic flux through C. And Faraday discovered that by moving this magnet magnet has produced magnetic field, right? So if you move magnet in and out of this metallic ring, you discovered that the voltage is induced at two ends. What happens if you have a voltage induced? It produces current, right? So this is basic idea about generator, generating electricity. And this is Faraday's law. So the Faraday discovered that by moving a magnet in and out of the closed metallic ring, a voltage is induced at the end. So there is a voltmeter is moving. So we discovered that by moving the magnet in and out of the closed metallic ring, that we discovered that the voltage is induced, or current is generated. So that is the invention of an electric generator. So we just applied Maxwell's equation and used Stokes theorem, and Maxwell actually predicted that using Stokes theorem that the voltage will be induced at two ends of the metallic current if you have a magnetic flux, time-varying magnetic field. And Faraday actually discovered that electric current can be generated. So that's the beginning of modern technology. So that's the reason why you're learning this vector calculus, or Stokes theorem is probably the most important mathematical theorem that changed the history of mankind. Because can you imagine that our civilization without electricity? I mean, if there's no electricity, then there's no projector. Maybe we have to have a candle, and maybe I have to use the blackboard to teach you. But after the end of the 19th century, that the engineers are very smart to apply the mathematical theorem called the Stokes theorem to practical problem, and then that's one of the ways that you can generate electricity. So before I proceed, maybe it's a good idea to take a break, right? What do you think? 2 minutes. 네, 맞아요. 뭔지는 모르지.
근데 중간까지 정리돼.
네, 왜냐면 미분으로 바꿀 때
네.
그 두 개의 값의 차이를 나눠준 거를 미분으로 바꿀 때
네.
어디서 미분한지 모르잖아요.
아, 그렇죠.
그러니까 그냥 바로.
그냥 바로.
네. 그거를 거꾸로 다시 뒤집을 수 있잖아요. 적분으로. 네.
그 다음 주 수요일 퀴즈잖아요.
네.
제가 그 전농수에서 달리기를 나가는데요. 그게 예선전이 다음 주 수요일 3시부터거든요. 그래가지고 혹시 퀴즈를 4시부터 달리기를 하는데 딱 그거 붙여갖고 혹시 퀴즈를 볼 수 있는 방법이 있을까요?
아 그래요? 4시부터라고?
네, 딱 붙여.
그럼 2시부터 보면 되겠네?
수업이 이게 2시 시작하죠.
네.
3시부터 달리기를 했었거든요. 네. 원래 그래서 1시간을 시험 볼 수 있는 시간이 그래도 있었는데 이렇게 줄여져갖고.
그러면 수업을 하지 말고 2시부터 볼까?
아니요. 시험을 2시간 동안 보고.
네, 2시간.
혹시 그러면 만약에 2시부터 보는데
네.
제가 1시간 더 먼저 와서 볼 수 있나요?
1시간 먼저 와서
네. 네.
1시간 먼저 와서 보면
저는 이제 3시까지만 보고 가는 거예요.
3시까지만 보고 가고
네, 1시부터 3시까지.
그러면 다른 문제로 보게 할게요.
다른 문제로?
왜냐하면 아무래도
네.
그러면 그 누구한테 얘기를 해야 되나? 지금 학생 조류가 없는데
네.
잠깐만. 이름이 어떻게 되지?
이름 김윤정.
빨간 글씨 쓰면 안 되지. 김윤정.
네.
이메일이나 뭐 있어요?
네. 이메일 DLSTK
STK
숫자 5 2개
55
네이버
DLS
T
T?
네 T
D가 아니라
네
KO
네 맞아요.
메일로 다음 주 수요일이니까
네.
학생한테 연결해 줄게요.
네.
DLSTK55
네.
네이버.com. 오케이.
감사합니다.
혹시 모르니까 나한테 이메일로 한번
네.
보내주세요.
감사합니다.
그러면 1시부터 3시까지.
네.
대신 문제는 좀 다를 거예요. 난이도는 비슷할 건데. 네.
아까 여기 설명해 주실 때
네.
여기까지 이제 이해가 되는데
네.
지금 여기서 인밸류 티어럼으로 인텔 적분기호가 없어지는데 마지막에 왜 다시 생기는 거예요?
라인적 선적분을 바꿨잖아요.
예.
선적분은 그러니까 중간값 정리 써가지고 이렇게 표현했지.
네, 적분기호가 없이 표현을 했는데
그래서 이거를 두 개를 더하고 나니까 이게 미분한 거잖아.
예, 그렇죠.
근데 이게 델타 X, 델타 Y가 있었잖아요.
예.
그러니까 이거를 중간값 정리를 써서 다시 바꿔주면은 2차원 적분으로 바뀌는 거지.
다시 중간값 정리로 다시 원래대로 바꾸는 거예요.
예.
그러면 여기도 그러면은 적분기호가 없어지는 게 맞는 거죠?
예, 그렇지. 어디가?
여기. 아까 제가 이렇게 써놨는데 여기 그럼 적분기호가 중간값 기호가
바는 없는 거지 이제.
감사합니다.
네.
여기서 그 2분의 델타 y 되는 게 이해가 안 돼서
여기 가운데 점 XY라고 했으니까
가운데 점을 찍으신 거예요?
여기 밑에랑 위랑 반값일 거 아니에요? 이쪽 반값.
그러면은 이 점이 뭐 어디 임의의 점일 때
임의로 점을 잡아본 거지.
그러니까 그 임의의 점이 그냥 가운데다.
네.
저번 주 건데
네.
이거 이게 뭐지 편도 미분을 두 번을 하는 거라고 제가 알고 있는데
예.
여기서 두 번을 하게 되면 똑같이 x, y, z가 사라지지 않나 해서 좀 여쭤보고 싶어서 그대로 y가 두 번 하게 되면 살아있어가지고 어떻게 되는지 잘 이해가 안 돼서 여쭤보고.
자, 여기에 대해서는 나머지는 이것만 살아남겠지?
네.
그러면 이거를 여기다 곱하고 나면 2y가 남을 거 아니야.
다시 한번 부탁드려요.
이거 풀어봐봐요.
이렇게.
네. 자, 첫 번째 거 다 무시하고 이것만 생각해 봅시다.
네.
이거는 0이지.
네.
이것도 0이지.
네.
이건 살아남지.
네.
2y잖아.
네.
이거.
그냥 근데
네.
두 번
두 번 미분 두 번 미분하면
그러면
어,
y가 사라져야 돼.
y가 사라져야지.
아 그럼 똑같이 다 y, z, x
예,
다
그렇지
사라지는
그렇지.
거야.
예. 내가 틀렸다. 예.
여기 아까 그 증명하실 때요.
예.
2번하고 3번
더하면
여기서 여기 가는 게 이해가 안 가가지고.
왜냐하면 이거는 지금 미분을 했는데 어딘지 모르는 값이잖아요. y바인데 이걸 중간값정에 한 번 더 쓴 거야. 거꾸로.
중간값정. 바가 미분을 했다.
중간 어딘가의 값.
어딘가의 값이요.
근데
이거를 왜 바로 적으신 거예요 혹시?
여기는 x, y, z로 바뀌는 거지.
중간값정대로요.
한번 다시 쓰면 거꾸로 하면은 이 값은 2차원 적분으로 바꿔줄 수 있는 거지.
근데 여기서 x 바만 정하신 건가요?
그렇죠. 왜냐하면 이건 이 선적분을 끄집어냈잖아요.
네.
선적분을 중간값 정리로 표현한 거지.
저는 그냥 이거 fx가 원래 x, y, z였으면
예, 맞아요. 예.
그냥 뭐
이거는
이게-
이제 그 선 밑에 그 선을 따라간 거잖아요. 이렇게. 이게 어디지? 이게 지금 이렇게 가고 있는 거잖아요. 그죠? 그죠? 여기 x, y, z니까 여기는 x. 요 점은 어떻게 되죠? x 마이너스 델타 y 오버 2c잖아요. 그죠? 이거를
이거를 중간에 있는 점이라 생각해서
네.
2로 나눈 거예요.
네, 그래서 이거 선적분을 하면 이게 A고 B잖아, 그죠? fx에 x, y, z에 dx만 있잖아요.
네.
그럼 중간값 정리했으면 어떻게 돼요? 근데 여기는 y가 y 마이너스 델타 y 오버 2지 밑에 있으니까, 그죠?
네.
그럼 이건 중간값 정리했으면 어떻게 되겠어요? 그냥 fx x반은 모르는 값이지만 y 마이너스 델타 y 오버 2 c에 델타 x겠죠, 그죠?
중간값 정리했어야 되구나.
예.
그리고 그 엑셀 저거 예를 들어주셨잖아요.
예.
근데 스트로크 시오름이 그게 의미하는 바가 어떤 부피가 있으면
선적분이 있는데 선적분을 회곡면을 따라 선적분을 한 거는 이 회곡면으로 둘러싸인 면에 대한 펄 값이잖아요. 펄 값이. 펄에다가 이 수직으로 된 벡터와 내적한 값.
내적한 값이
같다는 거죠. 스톡 세오럼이 그 얘기죠. This time we are going to cover the closed surface integral. So how many surfaces do we have for the given cube? 6, right? Correct. So 1, 2, 3, 4, 5, 6. So let's say X, Y, Z. So let's start with 1 and 2. And as before, I'm going to put center as a X, Y, Z. So at this point will be X, Y, Z minus delta Z over 2. So delta Z, delta Y, delta X. And this point too complicated, right? So let's just separate 1 and 2. So this point is X, Y, Z plus delta Z over 2. This point is given by X, Y, Z minus delta Z over 2. This normal vector is in Z direction, right? And this vector is minus Z direction. So one dr no 2 ds is basically 1 is this minus, so this is minus fz xyz minus delta z over 2 dx dy plus fc xy z plus delta z over 2 dx dy. So I'm going to move this to here. Then we can use a two-dimensional mean value theorem. Then we obtain the first value is minus fc x bar y bar z minus delta z over 2 delta x delta y plus fc x bar y bar z plus delta z over 2 delta x delta y is, maybe I should write down fz x bar y bar z plus delta z over 2 minus fz x bar y bar z minus delta z over 2 times delta x delta y. And then actually you can divide the whole thing by delta z and then multiply by delta z, right? So this becomes partial z partial fz x bar y bar z bar delta x delta y delta z. And then you can apply the mean value theorem again. Then it becomes partial z partial fc dx dy dz. You apply, use mean value theorem again. And then you can actually do the same thing for too complicated. I mean, the drawing is too complicated. So even for me it looks complicated. But the second figure is okay, 1 and 2, right? So we can actually do the same thing for 2 and 5. The next page, can I move on to the next page? 5, I think. 3 and 5. So this surface is 1, 2, 3, and this is 3 and 5. So for 3 surface, this is in x direction. And that is minus x direction, right? And assuming that the center is x, y, z, then the coordinate here is x plus delta x over 2, y, z, and coordinate here will be x minus, right? X minus delta x over 2, y, z. So this integral ds will be 3 is in positive direction, so fx x plus delta x over 2 y and z dy dz, right? Minus fx x minus delta x over 2 y and z. No, not yet. Okay. dy dz. And if you use the mean value theorem, you obtain this fx x plus delta x over 2 y bar z bar delta y delta z minus fx x minus delta x over 2 y bar z bar delta y delta z. Then you can put together fx x plus delta x over 2 y bar z bar minus fx x minus delta x over 2 y bar z bar delta y delta z. Then you can divide by delta x, multiply by delta x. So this is basically partial x partial fx x bar y bar z bar delta x delta y delta z three integral dx dy dz. Am I going a little too fast? So one final surface, 4 and can I move on or still is time? This is 4, this is 6. X, Y, Z. The midpoint is X, Y, Z. So this point will be X, Y plus delta Y over 2, Z. And this point will be X, Y minus, Y minus Y minus delta Y over 2Z. And the numeral vector is Y direction. This is minus Y direction, right? So 4 6 is basically Fy x y minus y plus delta y over 2z dx dz minus Fy x y minus delta y over 2z dx dz. Using mean value theorem, it becomes Fy x bar y plus delta y over 2 z bar minus Fy x bar y minus delta y over 2 z bar delta x delta z. And then you can divide by delta x y, multiply by delta y. So it becomes partial y partial f x y z bar delta x delta y delta z. It can be written as back as partial y partial f y x y z dx dy dz. Oh, so we have a very interesting result. So So if you've closed integral What is this? This is divergence F, right? And T3, volume integral. So it has a name called divergence theorem. Or Gauss theorem. So we learned two important vector integral theorem. One is a Stokes theorem. If you have a line integral, it becomes curl over surface integral, the Stokes theorem. And if we have a closed surface integral, divergence of F, T3. So following example. So any questions about Stokes theorem and divergence theorem? So these two are probably the most important mathematical theorem for the vector. And Stokes theorem is especially important because it was used to invent the generator. For example. So this is I can give the following example. So this is sorry. This is 0, 0, 0. 1. This is x-axis. This is y-axis. This is z-axis. 1, 0, 0. 0, 1, 0. This is 0, 0, 1. This point is 0, 1, 1. This point is 1, 0, 1. This point is 1, 1, 0. This point is 1, 1, 1. So I can give you the following S. And if F is given by X, Z. Assuming that I ask you to calculate this closed surface integral over vector F, what do you do? one thing is you can transform into volume integral, right? So what is divergence F? Hmm? 3, right. What is the volume? 1. So if you really like to do this surface integral, you can actually do that, but a bit complicated, right? 3. This is x, this is y, this is z. This is 1, 1, 0, 0, 1, 0. If f is given by x, y, z, y, zx, zx, y, what is this line integral? I can ask him to please factor this line integral. You can transform into this right? Called and what is called f? X, y, x. Partial x, f, y, z, right? And partial I, partial f, z. So z minus z is equal to 0. But if you really like to do the line integral, you can do that, but it will be a bit more complicated. Right? So that is some simple power expression that. So much for the Cartesian coordinate, and there are other coordinate systems, non-Cartesian coordinate, and some things we need to study a bit. 선수래.
이게 계속 녹음되고.
coordinate system. Other. For example, one of the most common coordinate system other than Cartesian coordinate is a cylindrical coordinate system. X, Y, Z. So it's like you have a z-axis and has a symmetry axis to the rotation. So any point is defined from zx I don't like this picture, but at some point, say z, distance. This is phi rho defined by rho phi z. So rho is distance from the z-axis. Phi is called azimuthal angle. Azimuthal angle from x-axis. So let's assuming that this point is x, y, z. Then rho is defined as the square root of x squared plus y squared. And phi is arctangent y over x, z is z. Then the question is, how do we define the distance between 2 points? So in Cartesian coordinate it's simple, right? In Cartesian coordinate, if x, y, z, x plus delta x, y plus delta y, z plus delta z. What's this distance? This distance delta z square, right? P to Q in Cartesian coordinate. However, in cylinder is a little bit different. 3시부터 뭐 달리기. So let's just draw a circle first. So this is a z-axis. So this is x, y, and I have to draw another curve. This is rho. This is rho plus delta rho. So what is this distance? Then say delta L rho. It's just delta rho, right? The distance between rho and rho plus delta rho. But on the other hand, if we have a case PQ, this is phi, this is delta phi, and this is rho. What is this distance? Distance between rho phi c and rho phi plus delta z, z. Let's say delta L phi will be rho delta phi, right? And distance between z plus delta z will be just delta rho z delta z. So so the question is then distance between point P rho phi z and Q rho plus delta rho phi plus delta phi z plus delta z ts square will be simply delta rho square plus rho delta phi square plus delta z square, right? Or in general, you can generalize this way. ds square is distance is d rho square plus rho square d phi square dz square. So distance is a bit different from the actual coordinate. Another commonly used coordinate system is spherical coordinate. I have an impression that I'm going a little bit fast, so I'll just try. So maybe I'm writing down too fast. Either way. Another interesting coordinate is spherical coordinate. This is basically a sphere. R theta phi. This is of theta, and this is a phi. So this is if it x, y, z. So R is defined as x square plus y square plus z square. Z, R over z is cosine theta. Or theta is cosine inverse c over r. Phi tangent inverse x over y. And this projection is actually r sine theta. So the distance between r theta phi and r plus t theta phi is tr square, distance between, and same as r theta phi, r theta plus t theta phi is same as before. R square d theta square, right? However, r theta phi plus d phi is a little bit different because this angle is actually r sine theta. So it's r square sine square theta d phi square. So the distance, in general, distance is ds square is dr square, r square d theta square, r square sine square theta d phi square. The question is, how do we represent gradient, curl, and divergence in this coordinate? So we like to cover a little bit more generalized coordinate. So the real question is, how do we represent divergence, gradient, and curl in this other than non-Cartesian coordinate? Done this way. Question: how do we represent gradient, some function, and other than Cartesian coordinate? So I like to generalize a general curvilinear coordinate. So Q1, Q2, Q3. And unit vector Q2, Q3 are mutually perpendicular. And the distance element, I'm going to write down simply DLQ1 as H1, Q1, Q2, Q3, TQ1, DLQ2, H2, Q1, Q2, Q3, TQ2, DLQ3 is H3, Q1, Q2, Q3, TQ3. So there's a distance along. So distance along Q1. This is a differential distance, infinitesimal distance along Q1 axis. This is infinitesimal distance between Q2 axis. It's the same as Q3 axis. Then we can define ts square is h1 square tq1 square h2 square tq2 square h3 square tq3 square. For example, cylinder coordinate is Q1 is rho, Q2 was phi, Q3 was z, right? H1 was 1, H2 was rho, H3 is 1. So we can have you can represent this way, or spherical coordinate. I have an impression I'm still going too fast. Spherical coordinate Q1 was rho r, Q2 was theta, Q3 is phi, and H1 1, H2 r, H3 r sine theta. This is a special case. But it is much more convenient just using this generalized coordinate of the linear coordinate. So gradient is easy. Gradient is between gradient f is actually q1 delta q1 delta f q2 delta L q2 delta f q3 delta L q3 delta f. So this h1 partial q1 partial f q2 h2 partial q2 partial f q3 h3 partial q3 partial f. So cylindrical gradient f is actually rho direction, partial rho partial f, phi direction 1 over rho partial phi partial f, z 1 partial z partial f. Spherical coordinate gradient f is rho partial r partial f theta 1 over r partial theta partial f phi r sine theta partial phi partial f. So before I cover core, maybe you can take a break, okay? 네.
다이버전스 티어럼 공부하실 때 그 중각 같은 거 2번 쓰신 거죠?
그렇죠. 처음에 한 번 써서 끄집어내고
그 다음에 다시 쳐.
집어넣을 때 항상 그렇게 했었어요.
예, 처음에 dx dy가 이게 미소
면적.
예, 면적이고 이거를 이제 나중에 적분으로 바꿀 때는
하나를
거리를 각각 떼서 버리고 쓰시고
그렇죠. 예. 맞아요.
여기서 원래는 여기랑 여기 사이의 거리가 2r이 되는 게 맞는 건데
계산상으로 편하게 할
스퀘어,
때 스퀘어를 붙이신 게
그렇죠. 네. 대현아, 그 여학생 한 명이 so let me see H1. So we are going to consider the closed line integral in Q1, Q2 plane first. So as before, I like to put the center as a Q1, Q2, Q3. And this distance is H1 delta Q1. But the difference between Cartesian coordinate and this case is actually H1 is also a function of Q1, Q2, Q3. So this point will be considered as Q1, Q2 minus delta Q2 over 2, Q3. This point will be considered as Q1, Q2 plus delta Q2 over 2, Q3. So 1, 2, 3, 4. So along this line, TR will be TQ1, Q1 direction, right? And this is minus in this direction. TR will be minus TQ1, Q1. So along this one, FTL will be, so this is A, B, C, D, is A, B, F, Q1, Q1, Q2 minus delta Q2 over 2, Q3, TQ1, right? Of course, H1, TR, TR is H1. Of course, we need to have H1 because this is the distance, actual distance. But H1 is also a function of Q1, Q2 minus delta Q2 over 2 Q3. So this is actually FQ1 Q1 bar Q2 minus delta Q2 over 2 Q3 H1 Q1 bar Q2 minus delta Q2 Q3 delta Q1. And likewise, 3 becomes minus, if you, so this is a use the mean value theorem. 3 will be minus FQ1 Q1 bar Q2 plus delta Q2 over 2 Q3 H1 Q1 bar Q2 plus delta Q2 over 2 Q3 delta Q2. Wow. So 1 plus 3. Probably some of you probably still need time to copy. So 1 H1, right? So okay, plus 3, we have minus FQ1 Q1 bar Q2 plus delta Q2 over 2 Q3 H Q1. Did I use H1 HQ1? H1 H1 Q1 bar Q2 plus delta Q2 over 2 Q3 minus FQ1 Q1 bar Q2 minus delta Q2 over 2 Q3 H1 Q1 Q2 minus delta Q2 over 2 Q3. This is delta Q1, right? So a bit complicated. So we divide the whole thing by delta Q2, delta Q2. Then what happens? It becomes minus partial Q2 partial FQ1 Q1 bar Q2 bar Q3 H1 Q1 bar Q2 bar Q3 delta Q1 delta Q2. But this is not the whole story, because if you like to change into surface integral, you need to have area. So area becomes H1 H2, right? And then you divide by H1 H2. At there, Q1 bar, okay. let's do this way, H1, H2 evaluated at Q1, Q2, Q3, H1, H2 evaluated at Q1, Q2 bar Q3. Then you can move back into sorry, I think I need a little bit more space. So minus H1, H2 partial Q2 partial FQ1, H1. This is H1, TQ1, H2, TQ2, TS. So if we do the same thing with the other part, 3 plus 4, I like to leave as homework then what happens? This integral becomes something like this. H1, H2 over partial Q1 partial FQ2 H2 minus partial Q2 partial FQ1 H1 TS. So that means this is the Q3 component of a curve. I think I'm going a little bit too fast. The Q3 component of a curve is actually Q3 is H1, H2 partial Q1 partial H2 FQ2 minus partial Q2 partial H1 FQ1. That's correct, right? Same as the book, right? And we can generalize the similar way this Q3 and okay, we can actually generalize for Q2, Q3, likewise for Q1, Q3 plane and Q2, Q3 plane. You can just, it's homework, or you can you can have a face. So trust me. But actually, you can do it. You can try to derive this at your home doing homework. F Q1 component is actually H2, H3, partial Q2, partial H3, FQ3, minus Q1, 2, 3, H2, FQ2. 1, 2, 3. 1, 2, 3, 2. And core FQ2 is H3, H1, partial Q3, partial H1, FQ1, minus partial Q1, partial H3, FQ3. This is 3. So core F can be written as the following. Q1 axis, H2, H3, partial Q2, partial H3, FQ3, minus partial Q3, partial H2, FQ2, plus Q2, H3, H1, partial Q3, partial H1, FQ1, minus partial Q1, partial H3, FQ3, plus Q3, H1, H2, partial Q1, partial H2, FQ2, minus partial Q2, partial H1, FQ1. I promised you I will find how to make a copy, so is it? No. Drop. Let me just try it. Okay, next time. So I just write down once again. Next page. So anybody follows how to remember that? Okay, core F start with Q1. There's a very simple formula. Always remember 1, 2, 3. So Q1 you start with H2, H3. And 1, 2, 3, partial Q2, partial 3. H3, FQ3 minus partial Q3, H2, FQ2. And plus this very nice symmetry. Q2, 3, 1. So H3, H1, partial Q3, partial H1, FQ1. So this is 3. Partial Q1, partial H3, FQ3, plus Q3, 1, 2. Partial Q1, partial H2, FQ2, minus FQ2, partial H1, FQ1. Okay, so cylindrical. Simple. Q1 is rho, Q2 is theta, phi, Z, H1 is equal to 1, H2 is equal to rho, H3 equal to 1. So curl F, rho direction, H2, H3, rho, partial phi, right? Partial, H3 is 1, Fz, minus partial Z, partial, H2 is rho, F phi, right? Plus phi, H3, H1 is all 1. So partial Z, partial F rho minus partial rho, partial Fz, C component, H1, H2, 1 over rho. Partial rho F phi minus partial phi, partial F rho. Spherical coordinate. Spherical coordinate. Maybe I should. Q1 is R, Q2 is theta, Q3 is phi, H1 is 1, H2 is R, H3 is R sine theta. So a bit more complicated. So I really like a small letter. Curl F, R. So H2, H3, R square sine theta. Partial theta, partial H3, F3, R sine theta, F phi, right? Partial phi, partial R F theta, right? Plus theta, H3, H1, R sine theta, partial phi, F R minus partial R, partial R sine theta, F3, plus phi, H1, H2, 1 over R, partial R, partial H2, F2, R, F theta, partial theta, partial FR. Okay. So you have all your expression for curve. So you have your gradient and curve. So next thing is divergence, right? Actually, divergence is also quite easy. You just need how to draw the general cube. So you have a generalized curve cube. So let's just have two components. This is minus Q3 direction. This is Q3 direction. If you set the center as Q1, Q2, Q3, then this point will be Q1, Q2, Q3, delta Q3 over 2, right? This point will be Q1, Q2, Q3 minus delta Q3 over 2. And this is H1 delta Q1, and this is H2 delta Q2. So this is U1, 6, So 1 plus 6 is actually this. 1 plus 6. You have this integral. And it's pointing FQ3, H1, H2, TQ1, TQ2, right? Add Q1, Q2, Q3 plus delta Q3 over 2 minus FQ3, H1, H2, TQ1, TQ2 at Q1, Q2, Q3 minus delta Q3 over 2. So you can follow my logic that, right? So if you use a mean value theorem, what happens? This is
Veuillez d'abord déverrouiller votre iPhone.
sorry, I sent my theory in French because I'm studying French, and she's saying this is time to whatever. So F3, H1, H2, this is a Q1 bar, Q2 bar, Q3 plus delta Q3 over 2 minus F3, H1, H2, Q1 bar, Q2 bar, Q3 minus delta Q3 over 2, delta Q1, delta Q2. So you actually start with dividing by delta Q3, delta Q3, right? And then you multiply by H1, H2, H3, and divide by H1, H2, H3 at Q1 later. Then maybe I can use, it may be better to use on the same page because it's going to confuse you. So it's going to be partial Q3 partial F3 H1 H2 evaluated at Q1 bar, Q2 bar, Q3 bar, delta Q1, delta Q2, delta Q3. So now you divide by H1, H2, H3, evaluate at the mean value, H1, H2, H3 at the mean value. Then it becomes following. H1, H2, H3, partial Q3 partial, F3, H1, H2 times dV. So you can continue to add other two parts as well, right? So likewise. So can I move on? Or I think I'm really going fast. But actually it's the same method. So if you come back to this one, H3, so likewise, another part as homework you can do at home. So closed line integral f ds can be as follows. H1, H2, H3, partial Q1 partial, FQ1, H2, H3, partial Q2 partial, FQ2, H3, H1, partial Q3 partial, Q3, H1, H2, dV. So this is actually divergence. divergence of F is H1, H2, H3 partial Q1 partial FQ1, H2, H3. So there's nice symmetry. Partial Q2 partial FQ2, H3, H1 partial Q3 partial FQ3, H1, H2. Actually, in the class, I only showed this part only, but the other two as homework, you can do that, right? But it's very nice. Once you have done that, then the other must be similar. So we have a formula for divergence as well. So for your reference, next page. So it's easy to remember. So let's just try it once again together. Divergence of F is you divide by H1, H2, H3, common factor. Partial Q1 partial FQ1, H2, H3. Partial Q2 partial FQ2, H3, H1. Easy, right? Q3, H1, H2. So cylinder. Cylindrical coordinate. Q1 is rho, Q2 is phi, Q3 is z, H1 is 1, H2 is rho, H3 is 1. So divergence F, H1, H2, H3 is 1 over rho. Partial rho, partial F rho, rho, partial phi, partial, this is just F phi, right? Partial z, partial F0. Spherical coordinate. Q1 is R, Q2 is theta, Q3 is phi, H1 is 1, H2 is R, H3 is R sine theta, right? So divergence of F is simply 1 over R square sine theta, partial R partial FR, R square sine theta, right? Plus partial theta partial F theta H3 H1 R sine theta plus partial phi partial F phi R. Laplacian divergence over gradient. It's a bit divergence over gradient of F is simple. H1, H2, H3 partial Q1 partial. This is F1, H1 over FQ1, H2, H3, right? No. 1 over H1 partial Q1 partial V H2 H3 partial Q2 partial H2 partial Q2 partial V F partial F H3 H1 partial Q3 partial H3 partial Q3 partial F H1 H2. So cylinder. So cylindrical coordinate. Okay, Q1 is rho, Q2 is phi. I think I'm really going fast. See, H1 is 1, H2 is rho, H3 is 1. So, divergence of gradient of phi is 1 over rho, partial, rho, partial. H1 is 1, so partial, rho, right? Partial phi, partial, H2 is 1 over rho, partial phi, partial F, H3, H1 is 1, plus partial phi, partial, H3 is 1, so partial phi, partial, H1, H2 is rho. So maybe a little bit more simplified. We can have 1 over rho, partial rho, partial rho, partial rho, partial F. Rho can be put out of the matrix. Partial phi square, partial square F, plus partial phi square, partial square F. So that's a Laplacian for the sphere, cylindrical coordinate. So rho phi is independent coordinate. So when you differentiate by rho can phi this can put out because they're independent. Of course, you can put out this, right? They cancel each other. And finally, so can I move on to the next page? Spherical coordinate. Q1 is R, Q2 is theta, Q3 is phi, H1 is 1, H2 is R, H3 is R sine theta. Okay, so let's just play with our memory without writing down. Okay, so divergence of gradient to F is 1 over H1, H2, H3, R square sine theta, partial R partial 1 over H1 is 1, right? So partial R partial F 2 set R square sine theta, right? Because H1, H2, H3 plus partial phi partial, and we have 1 over H2 is 1 over R in front of here, right? Oh, no, sorry. In the parenthesis. Partial phi partial 1 over R, partial phi partial F, right? And H3, H1 is R sine theta. Because 2, 3, 1. So H3, H1 is R sine theta. Plus theta, sorry. This is theta. Partial phi partial 1 over R sine theta, partial phi, partial F, H1, H2 is R. So let's see if we can simplify things. So the first one, actually you can move sine theta out because it's derivative by r, right? And sine theta will cancel each other. So 1 over r square partial r square partial r partial f plus this r can cancel each other. So r square theta partial sine theta partial f. Here r cancels each other and sine theta can be put out, so it becomes r square sine square theta partial phi square partial square f. So in the quiz, I will give you some functions in r theta phi or rho phi z, and then ask you to calculate curve, gradient, and whatever. So the possible I think I really have done really fast. So homework, design F in cylindrical and spherical coordinate, calculate gradient F, curl F, divergence F, divergence gradient F. Maybe your own problems. So maybe 5 set each, 10 problems for you. 10 problems. So you just design your own problem and then try to solve those, calculate those things, those quantities at home. You will probably do your best preparation for the quiz. Oh, I think I have done enough for today. So maybe stop. We have a 1 hour class next Wednesday, and after that, 2 hours quiz. Be prepared because you will be very busy.